In this session, we will discuss about thermochemistry. Thermochemistry. Now, in this chapter, we will talk a lot about energy. You might have known two different forms of energy from physics. For instance, the potential energy, and also the other one would be the kinetic energy. Now, in this chapter, you will also be introduced to the term of internal energy, which is basically the combined kinetic and potential energies of atoms and molecules that make up an object. They constitute the internal energy of that object. As we saw in previous chapters, in the chemical reactions, we are often see the forming and also the breaking of chemical bonds. Now, if the amount of energy liberated in a making of a bond is greater than consumed in breaking of the bonds, we call that this process releasing chemical energy. The unit for energy is called joule, symbolized by J, and 1 joule is equal to 1 kilogram meter squared divided by second squared. Although we can use a wide variety of classifications for types of energy, all energy flow is either heat, symbolized as Q, or work, symbolized as W. Heat is the flow of energy between two objects due to the difference or delta in temperature. The heat will flow from warmer to cooler object. On the other hand, work, or W, is actually a transfer of energy accomplished by a force moving a mass to some distance against resistance. Now, in chemistry, the most common type of work that we will encounter in chemical processes is actually the PV, or pressure volume work. For instance, if we take a look at combustion reaction, like hydrocarbon, CXHY, being combusted and form CO2 gas, plus water vapor used in propelling a car. The combustion of the hydrocarbon produces carbon dioxide and water vapor, and those gases do the PV work to then expand against the piston in the engine cylinder. This PV work is then transmitted through the engine to move the car or producing the mechanical energy. And this is the type of work that we will discuss mainly in the thermochemistry chapter. The object that we focus on is called the system. And the remainder we call the surroundings. And together they make up what we call the universe. The system and the surrounding are separated by a boundary. The boundary may be a physical container, but they could also be a more abstract separation. Now we have an open system where materials or mass and energy can flow freely from surroundings to systems and vice versa. We have a closed system in which only energy can flow freely, And we have an isolated system where neither mass nor energy can flow between the system and the surroundings. As we mentioned that heat and work are the only possible forms of energy transfer, we can attribute the overall change of the energy of our system will be equal to the heat and also the work. The delta here, as you might have known, meaning change in, and it is basically the final value subtracted by the initial value. The convention, that is, the energy that is transferred into the system, is given a positive sign, and vice versa, when it is flowing out of the system to the surroundings, we give this a minus sign. For instance, if a heat flows from the surroundings into the system, then the Q is positive. But in the opposite, if the heat is being released from the system to the surroundings, then the Q will have a minus sign. On the other hand, if the work is done on the system, then the W is positive. But if the work is done by the system, then the work will have the negative sign. So anything that goes in to the system, we give a positive sign, and anything that goes out or being done by the system, we give it a negative sign. The change in the internal energy of the system is exactly offset by the change in the internal energy of the surroundings. And therefore, the energy of the universe is the total energy of the energy of system and the energy of surroundings. The change of the energy of the universe will be equal to 0. Or, in another word, we can say that the energy is conserved for the universe. Energy cannot be created or destroyed, but they can only be transformed from one form to another. And this is what we call the first law of thermodynamics. The conserved energy of the universe.